Number one, a child slides down a slide. Here is a child who is going to slide from here, here. Okay. The weight of the child is 250 newtons. The the height of the child is 7 meters. Here is the height. Okay. The work done against friction as the child travels down the slide is 1300 joules. So this is the amount of energy which is used as a work done against friction. Okay. What is the change in gravitational potential energy and what is the final kinetic energy of the child? Okay. So let's calculate gravitational potential energy. We know that gravitational potential energy is mgh, and we know that mg is actually the weight of the object, so we can replace mg with weight times height. So now we can replace the values. Weight is 250 and height is 7, so it is 1750. Okay, so when the child is here, it will have 1750 gravitational potential energy. The gravitational potential energy would be 1750 at this point. When the child will come here, at this point, its height is 0. When height is 0, then gravitational potential energy will be 0. See how? So gravitational potential energy would be 0. At top, its gravitational potential energy is 1750. Here it is 0. So the change in gravitational potential energy would be the difference between them. So you can see 1750 was at top. At bottom, it is 0. So overall, the change in gravitational potential energy is 1750. Okay. So next is the work. Here is the work done against friction as the child travels down is 1300. So at top, it was 1750 as a gravitational potential energy, out of which 1300 is used against friction. So we can find out that out of 1750, 1300 is utilized against friction. So we are left with 450 joules energy. 450 joule energy is left. And when this child will reach here, it would be in state of motion. And due to motion, that remaining energy would be its kinetic energy. Here it has 1750 as a potential energy. When it was going in downward direction, some of the energy was wasted against gravitational, against friction. And when the child will reach here, it would be in state of motion, and there would be no height. So no height means no potential, gravitational potential energy, and only kinetic energy. So this 1450 is nothing but only kinetic energy. So you can say it is kinetic energy. So kinetic energy is 1450. So how much energy is changed? Energy was 1750. At the bottom, it is 0. So change in gravitational potential energy is 1750. So these are two possible options. So kinetic energy, final kinetic energy is 1450. So this is the only correct option. So this is the final answer for question number 1. Okay, what uses non-renewable energy? Non-renewable energy is which can be reproduced, and non-renewable energy means which cannot be renewed. Wind turbine uses renewable energy. Solar panel uses renewable energy. A nuclear power plant. A nuclear power plant is using some nuclear substances, and geothermal heating energy is an infinite amount of some lava. So I think so. Nuclear power stations are using non-renewable energy resources, which are their like their amount is going to decline in coming days. So that's the only possible option for me. Which process in the sun produces energy? We know that in sun there is a nuclear process, and radiation is actually the outcome of energy. Burning is not occurring. There is no burning process there. Now nuclear fission and nuclear fusion process in solar system, we know that it's a nuclear fusion process, like two small elements merge together to give energy. That is like to make a heavier element, and the energy is released. That is nuclear fusion process. A 300 Newton force is applied to a box to move it up a ramp. 300 Newton is applied on this box to move it upward like this. How much work is done by the force when moving the box from X to Y? So we know that, okay, the distance you can see The displacement from x to y is 5 meters and the force is 300 newtons, and there are no symbols of like friction, so we are going to ignore the frictional element. So okay, so 1500 joules is the amount of work done on this object to move it from x to y, and then we will find that some of work done is converted into potential energy, some work is done again into potential energy, and some against friction and like that. So for right now, this is the correct option. A cyclist travel along a horizontal track at a constant speed. Constant speed means there is no acceleration. The work done by the cyclist is equal to, okay, now it's a horizontal track. Horizontal track. So the work done by the cyclist is equal to change in kinetic energy. Okay. So we know that when object is moving on a ground, then work done would be equal to kinetic energy of the object. So this is the possible option. And rest of the options are like the force of air resistance is has no link uh, with work done, friction force, similarly thermal energy. A 2 kg mass, so mass is 2 kg, has 300 joules of kinetic energy. Kinetic energy is 300 joules. What is the speed of the mass? So we can use kinetic energy is half mv square. So kinetic energy is 300, which is equal to 2 mass is 2 kg, and then we have v square. 2 is cancelled. So 300 is equal to v square. So by taking square root on both sides, so v would be equal to, so it is approximately 17.2. You can check with calculator. So it looks that approximately this is the correct option. Okay. A rocket of total mass m is traveling at a speed v. Okay. The engine of the rocket is fired and fuel is used up. Okay. The mass of the rocket decreased by half and its speed increased by 2v. What happened to the kinetic energy of the rocket? So it is very simple. We know that kinetic energy is half mv square. So according to mass is reduced, mass became half and speed is doubled. Speed is doubled. So what will happen is, so I'm going to call it as a new kinetic energy. I'm going to mark it as a prime. So it would be half mass over 2 and it would be 4v square. So I can cancel out this one with the 2 and then I can take 2 outside and we are left with half mv square. So half mv square is previous kinetic energy So new kinetic energy would be twice then previous kinetic energy. So it would be double. When mass is halved and speed is doubled, then overall the kinetic energy would be doubled. So our option is this one. It halves, it increases, it stays same. That's wrong. All are wrong options. A builder a builder lifts 8 slabs from the ground on the back of a lorry 1.5-meter high. The total time taken is 48 seconds and each slab weighs 200 newtons. So the weight of each slab is 200 newton. And there are 8 slabs. 8 times 200. So total weight is 1600. And from the ground to the back of lorry, which is 1.5 meters. So height is this is height. Height is 1.5 meters. So we can do it like this. Like we know that potential energy is mgh